Let's now look at domain and range of quadratic functions in the general form. We are now narrowing down our discussion to the general form. And we have stated earlier clearly that the domain is always a set of all real numbers, whether it is in the vertex form or in the general form. Our domain is always a set of all real numbers. And we have seen the general form is f of x equals to ax squared plus bx plus c. And we said already that a is not 0, but can be more than 0 or positive, or can be less than 0 or negative. And I have 2 points here which are very important. The first point is, if a is positive, that is, if the coefficient of x squared is positive, then the range y is more than or equal to k. I did not define the terms, but they will be defined down below shortly. K is the y coordinate of the vertex. So if a is positive, then the range y is more than or equal to k, where k is the y coordinate of the vertex. If a is positive, our curve looks like this. That is, if a is positive. If a is positive, then our curve has a minimum turning point. And the second key point is, if a is negative, then the range y is less than or equal to k. Still, k is the y coordinate of the vertex. If a is negative, our curve looks like this. This curve opens down, or it has a maximum turning point. And in the first case, our curve opens up. It opens up and has a minimum turning point. So this is our focus when we are getting the range. We simply find k. After getting k, then we look at a. If a is positive, our range is more than or equal to k. But if a is a negative, then our range y is less than or equal to k. And below here, we have defined the terms. We have said k is the y coordinate of the vertex. And this is the formula for getting k. For you to get the y coordinate of the vertex without plotting or drawing the quadratic curve, then our k is 4ac minus b squared out of 4a. If you substitute for the respective values here, you get the y coordinate of the vertex k straight away. What do we mean here when we talk about the y coordinate of the vertex? If this is our quadratic curve, any curve, I'm going to sketch it in any manner, assuming I have a maximum turning point in this case. This is the vertex. Now this point is what we call the vertex. That is the point, the turning point. In coordinate geometry, any point has two coordinates. It has the coordinate on the x-axis and a coordinate on the y-axis. The coordinate on the x-axis, this is the x-axis, that is the y-axis. The coordinate on the x-axis is what we call h. So h is the x-coordinate of the vertex here. The x-coordinate of the vertex is h, and the y-coordinate of the vertex is k. So if I say the y-coordinate of the vertex, I am meaning k, and that means that is the coordinate on the y-axis at the vertex or at the turning point of the curve. When I say h, I mean the x-coordinate of the vertex or the x-coordinate of the turning point of the curve. So k is the y-coordinate and h is the x-coordinate of the vertex respectively. Therefore, for us to get the x-coordinate of the vertex, which is h, it is given by negative b out of 2a. That means you just look at your quadratic function, deduce for the value of b and the value of a, substitute them here, and you find h. That will be the x-coordinate of the vertex. And you also do the same when you are getting k, as I explained. Both k and h help us, they assist us in finding the range of the quadratic function. As we have said, that the range depends on the vertex or on whether the curve opens up or down. So k and h assist us in finding the range of a given function. So this is the overview and introduction to domain and range of quadratic functions. We said we are going to take only two forms, that is the general form and the vertex form, and then we have discussed the introduction to the general form very clearly. Therefore, we shall be going to examples, and by the time we do the last example on the general form, you shall be in position to clearly understand and visualize what we mean when we talk about the domain and the range of quadratic functions in the general form. Otherwise, thank you.